This example is a little bit more complex compared to the previous one, because in this circuit we have 3 power supplies. But the process to solve it is exactly the same as what we had from the previous problem. So step 1, we're going to first break down this problem into 3 smaller problems, with each problem only have 1 power supply. So the first part of the circuit, we only keep the 12 volt power supply, and we set all the other power supply to have a 0 value, which means we have an open circuit over here and open circuit over there. Let's draw the circuit. This completes the first part of the circuit. In the second circuit, we're going to keep this 6 milliamp current supply. So we know that this will be replaced by a wire, so that the voltage drop between these two nodes will be 0, and this will be an open circuit. So let's draw the circuit. And the third part, we're going to keep this 4 milliamp current source and set all the other power supply to 0. The same thing, we're going to replace this by a wire and leave this branch open. So we have the circuit diagram like this. And this is a I naught triple prime, and the I naught double prime is here. So step 2 is to solve these 3 problems together to get I naught prime, I naught double prime, and I naught triple prime. Towards the end, we're going to add these 3 together to find I naught. So let's solve for the first part first. We can find the current fairly easily. I naught prime, that is equal to the voltage applied on there, that is 12 divided by 6 plus 6, but in the reverse direction. So we have a -1 milliamp. In the second part of the circuit, because this is 6K and another 6K are shorted by this wire, so we know that I naught double prime, that is equal to 0. And the third circuit needs a little bit of calculation. This part of circuit that is shorted. So we'll only need to deal with the right hand side. So 6, this is 6, and this is 12. And the 2 branches connected at this node have the same resistance, 6 kilo ohm and 6 kilo ohm. We know that the current going through the 2 branches are even. So we find I naught triple prime, that is equal to -2 milliamp. Pay attention to the direction of I naught triple prime, which that is different from the current direction of this power source. Then we can write the conclusion. Say I naught, that is composed of 3 parts, I naught prime plus I naught double prime plus I naught triple prime, that give us -1 plus 0 minus 2, that give us a -3 milliamp.